Hola? Perfecto. I am really excited to be able to speak to you today.
Estoy
It's been
emocionada de
wonderful.
estar aquí.
So many good Argentinian friends over the last few days.
Es
I've
muy
had
bueno
some
encontrar
fascinating
amigos.
conversations
He
and
tenido conversaciones
some
muy
amazing asado
fascinantes.
also. Muchas gracias, Ariel.
Me gustó mucho el asado.
Let's
Muchas
thank
gracias.
Juan and Ariel and all of the organizers for putting together such an amazing conference.
Muchas gracias por organizar una conferencia así.
So yesterday, Daniel and Audrey were saying you shouldn't be shy to upload new packages to
Dijeron, no
PyCon.
debería ser
And I agree. Or
tímido.
maybe I just have no self-control. Because I maintain something like, I think, 18, I counted yesterday, 18 packages on PyPI. And a lot of those are libraries. And so I've had a lot of opportunity to think about what constitutes good API design. I'd like to share with you today what I've noticed. Now, I'm giving this talk in English today because your English is a lot better than my Espanol. But this is just the first of many choices about language that we're going to make over the next hour. I love language, but I would not consider myself a poet. However, poets and programmers have a lot in common. We both deal with very precisely formatted language. We both make up new terms. In fact, every time you make a new variable and give it a name, or call it a new function, you are inventing a new piece of language. Now, it's this invention of language, along with all the mental processes involved behind it, that are key to writing excellent APIs. Now, it's vital that we create our new language with care, because the language that you use influences the thoughts that you can think, or the thoughts that anyone can think, if they're using that language. For example, who's ever had someone tell them, go learn Lisp, go learn Haskell, it'll change the way you think about programming.
¿Por qué no programas en tu lenguaje y cambiar la manera que piensas de la programación?
In fact, there used to be
Hay una teoría psicológica,
not sort of theory, but a hypothesis
es una hipótesis que se llama de Sapir-Whorf, que dice que las palabras que usamos limitan los pensamientos que tenemos.
Some supports in its favor, some anecdotes.
Hay anécdotas que la respaldan. Por ejemplo, hay un hombre mexicano, Ildefonso, que nació en una familia pobre, sordo, no tenían recursos para invertir en lenguaje de señas o leer los labios. Entonces creció hasta los 27 años sin saber nada de lenguaje. Era una persona sin lenguaje. Como resultado, no tenía poder. No podía contar más allá de 10 por razones obvias. Pero después, cuando sí pudo tener su lenguaje, pudo hacerlo bien. Tuvo herramientas. Una fuerte hipótesis ha sido refutada por otros ejemplos. Las traducciones satisfactorias son posibles. Por ejemplo, tenemos Wittgenstein, un filósofo muy famoso. Podemos traducir su alemán al castellano y todavía tiene sentido, o el sentido que Wittgenstein quiso dar. Pero cada lenguaje tiene su sabor. ¿Quién no ha acusado a alguien de usar Java?
Oh, you're writing Java in Python. Stop that. That's terrible. Yes. Or you work with a functional programming person and they're like, oh, stop writing
si usamos lenguajes funcionales
or in Haskell or whatever.
En lugar de ML o Haskell, estaría usando map y fold.
They draw you that way. They influence you. Python makes you use hash tables for everything. You can make
Por ejemplo, Python nos deja usar tablas hash.
JavaScript, everything is a closure.
En Java todo es un cierre. Esta es una forma débil de la hipótesis que sí se mantiene, que el lenguaje que usamos influencia los pensamientos que tenemos. Y los límites de esta influencia han sido marcados experimentalmente.
there are not a lot of English words for colors
No hay
between
muchas buenas
red
palabras
and
para
orange.
colores entre el
Espanol
rojo
has
y el naranja.
rojo and naranja. Now, are there other words in between, such that if
Hay
I
otras
showed you a
palabras en
swatch, you would probably come up
en
with the
el medio
same word as your neighbor? Not so much?
que no es la
Yeah,
misma palabra
it's
que el
a
vecino.
common poorness of our languages. What happens is if you show people in an experiment all these swatches between red and orange,
Todas las muestras
they
entre
can
el
certainly
rojo y el
distinguish them
naranja
visually.
pueden
Obviously, you can
distinguirlas
tell the
visualmente.
difference. But then if you distract them with a
Pero
card game
después, si los
and bring them
distraemos
back 10 minutes later,
y los
they will
traemos de
not be able
vuelta,
to recall
no
or
van a ser
remember which
capaces
swatches
de
they had seen
recordar
before.
cuál
They
era
didn't
la
have
muestra que le
a
habíamos
symbol,
mostrado,
an ability to do recall
porque no
if they didn't have
tenían
a name.
un símbolo para recordar.
So it seems like having a symbol,
Entonces
having a name
parece
for
que
something
tener
makes it mentally
un
lighter
nombre
weight.
para algo lo hace
When you draw a
mentalmente más
category
liviano.
like red
Cuando
over a bunch of details
usamos
like
una categoría
630
rojo
to
con un
670
montón de
nanometers in wavelength,
detalles numéricos,
you get a mental abstraction, and you can kick all those
usamos
details,
mucha
those
abstracción
nanometer
y
measurements out of
sacamos
your
todos los
head,
detalles.
leaving room for building higher level
Dejamos
constructs,
lugar para
like sentences
construir
with the word
sentido
red.
con la palabra rojo.
So abstracting out symbols, I would hold,
Abstraer
is the root
símbolos
of all human
es la
language.
raíz de todo lenguaje,
But it's also the root of all
pero
software
también la raíz de
engineering.
la ingeniería de software.
The point of software engineering, I
El
would say,
punto
the
de
thing
la
that
ingeniería de
distinguishes it
software
from
es
just hacking
la
around with spaghetti
diferencia
code,
de estar
is
escribiendo con espagueti,
making
es
software
hacer que el
algorithms
software
intellectually intelligible
sea
by
inteligible
finding good abstractions.
intelectualmente,
So let's talk about
encontrando buenas
APIs.
abstracciones.
In creating an API,
Al
you make
crear
up your
un
own
API,
symbols and their
inventamos
meanings,
nuestros
functions,
símbolos y
classes,
los
variables, and so on.
significados, funciones,
With the
variables.
names and the semantics that you choose,
Y con la
you shape
semántica que
all the
elegimos,
future thought
vamos a
about
dar
that system.
forma a todo
Have you
pensamiento
ever started
futuro
using a
sobre ese
system
sistema.
and you just can't understand the abstractions and what did you mean by thing? You know, someone calls a variable foo or
¿Qué querías
a class
decir con
thing. It doesn't help.
thing,
You have
por
no idea
ejemplo?
what's going on. You have to reverse engineer everything,
No nos ayuda,
keeping
porque
the
primero
details in
tenemos
your mind. And you have a limited amount of mind. I have a very small working memory. That's why I have to choose good names for
tengo
things so
una
that I
memoria
can
pequeña,
work at a high
entonces
level of abstraction.
puedo trabajar las
Ildefonso
abstracciones.
could not get above 10
Ildefonso
until he had the
no pudo
symbols for
contar
it.
hasta 10 hasta que tuvo las
So when you make
palabras
a good
para hacer.
API, you provide
Cuando
other
creamos
people,
una buena
or
API,
your
le
older
damos a
self,
los
after
que
all, we're
vienen
all a different
después
person 6 months after
y
we've
todos
looked
los
away from the
demás,
code. You provide them those numbers after
les
10,
damos
making
esos
things
números
mentally
después
lighter
del
weight
10.
so that you can think thoughts that you couldn't before.
Así tienen
Let's take a
pensamientos
look
que
at some
antes no
code.
tenían.
So this is URL lib2.
Veamos un
Isn't
ejemplo.
this nice?
Esto es URL lib2 versus request.
It's a library in the standard lib. You're familiar with it. It
Es una librería.
has a tendency to be a bit verbose and hard to do things that today are common, like HTTP requests. Though, of course, it has a larger scope than just HTTP.
HTTP.
But in today's webby port 80 world, requests, a third-party library, has come to dominate Python web programming.
Request es una
And
librería
that's
de
because
terceros.
it uses this de facto standard category called the
Se ha
HTTP
convertido
request.
en estándar de hecho.
It exposes things at
Introduce
this higher level of abstraction.
un nuevo
In
símbolo.
fact, the brilliant thing here is it exposes a
Hay una
level of
cosa
abstraction,
brillante,
a symbol
una doble
that people already are
abstracción.
familiar with. So one easy win when designing an API is ask yourself, are people already having a symbol for this piece of work? If so, just make that symbol work. Just breathe life into it. Now, it's silly to try to turn good design into a series of steps or a mechanical process you can follow. So let's do it anyway. I'm going to give you 7 rules of thumb that you can use as a checklist. Now, you're not going to get good design for free out of here, but this will certainly help you avoid a lot of wrong turns and keep you from falling off cliffs. The first rule of thumb today is something not to do. And I usually think of this in terms of libraries, but it applies to a lesser extent to all APIs. Don't be an architecture astronaut. The first step in designing a new library for me is to resist designing a new library. It's all well and good to seek to do good design in the abstract, right? But design is basically just imagination. And imagination is nothing more than hypothesizing. And we all know what happens with hypotheses if they aren't continually brought back down to earth and tested and banged against reality. You end up with something like alchemy rather than chemistry. Now, alchemy can be very impressive to look at. I don't know what's wrong with this guy over here. But it can be academically interesting. It can be have lots of flashes of color and such. But really, when it comes down to it, it's merely a self-consistent system of nonsense. You can't actually get any lead out of this gold, or gold out. That'd be cool too. But lead, what they wanted, gold out of this lead. That's it. So let's bring our efforts back down into the realm of science and keep in mind that the best libraries are extracted rather than invented. And what this means is that you should have an application or 2 or 3 or however many you can that already does the task provided by your library. And then take those common bits, those common implementations, and factor them up, pull them up into the library. And you'll be taking into account a wider range of applications. Be more likely to be reusable later. For example, I wrote this plugin called Nose Progressive. It's for the popular test runner called Nose. And its purpose is to display a little progress bar and display tracebacks as you're running the tests, and format them so that they're easier to follow visually. Purple function names, for example, on the right. Now, it makes a lot of use of terminal escape codes for things like bolding, coloring, and positioning. And the code looks something like this. Now, there's a lot of terminal setup and bookkeeping all intertwined with the code that actually keeps track of tests. So this is really hard to read. Don't blame yourself. This is bad. And there are raw terminal capability names from 500 years ago, like SGR0 and RC, that I had to keep on looking up as I was writing this. Every time I'd have to do some formatting, I'd think, geez, I wish there was a decent abstraction or at least some different naming around here so I wouldn't have to look at this and remember it. And it's at this point, this is the feeling you're waiting for, when you have a real working program with a library struggling to get out, that it's okay to start designing a new library. So it was time to extract this terminal handling, which eventually became my library, Blessings. Curses, Blessings. Let's use that as an example. So, what was my thought process? Well, the first thing is to dump everything out onto the table. What sorts of things ought the library to do? Well, we need to print some formatted text, obviously. And then, in the case of Nose Progressive, I found that I needed to move down to the bottom of the screen, print some text, and then snap back to where I began. So what tools do we have on our workbench? Here are our tasks. What are our tools? Well, we have all the stuff that's already in the language. We have functions, arguments, positional ones, keyword arguments. We have decorators, context managers. Those are a favorite. And classes. And then, of course, we have common patterns as well. Now, these can be things that have special support built into the language, or they can be sorts of things that arise from a community of practice around a language. In the case of Python, we have protocols like sequences, iterators, and mappings, dictionaries and such. Now we have everything out on the table, and we shake the table up and try to find good pairings between these items. What guides you in this? Well, consistency, our second principle. We are fortunate to have the entire cultural and technical weight of the language proper, as well as the accumulated habits of the programming community behind us. So we are not alone when we try to be consistent. We have things to be consistent with. When we're designing websites, which we do quite a bit, at least I do, at Mozilla, we think of it this way. People spend 90% of their time on other people's websites. So go ahead, put your logo in the upper left. Make clicking on it go to the home page. Put the login link in the upper right. Make your links blue, and so on. Don't violate people's expectations. When writing an API, realize that users will spend 90% of their time calling other people's APIs. So if you need to, you can be weird and clever. But if you can manage to stick with conventions, you'll get a lot of bonuses. First, you will convey respect for your users. You're not some outsider porting a Java library who's going to camel case everything and make everyone instantiate 6 objects to get anywhere. 2, you are going to get learning speed and retention. If your library is the same as everything else, there's nothing new to learn and less to remember. One of the brilliant things about the early Macintosh project was their explicit written human interface guidelines. Every program had the same commands: open, close, quit, copy, paste. They were in the same menus and had the same keyboard shortcuts as well. So in a very real sense, when you invested in learning one program, you had learned them all. Now, API design can reuse most of those principles from user interface design. For example, the principle of least astonishment, least surprise. Now, what that means is do your best not to surprise the user. Surprise is fun in games, but not so much in APIs. So if you implement, let's say we have some kind of, key value library that sits on top of a Redis store. We should call our method something like get, and let the arguments be key, and then default. We should not call it fetch and reverse those arguments, because there's no precedent for that in Python, and there's no benefit from doing it differently. This leads us to a third benefit of being consistent, which of course is polymorphism. Pretend this is our Redis thing. Well, if we're writing a test for something, a unit test, or maybe we're just deploying a very small blog, we could just use a Python dictionary, substitute it right in for this, and everything will work just the same. So coming back to our terminal formatting example, how can we pair up these tasks with existing language features and conventions? Well, I like to get as many alternatives out on the workbench as possible. And I call these my sketches. Now, there are really only 2 choices I could come up with for printing at a location. Both are okay, but this first one is just a function call. This second one, though, that uses a context manager, this has some advantages. This has some additional power, even though it's longer. It gives us the flexibility to put multiple statements inside, loops, even calls out to other functions, and the first, which is shorter, can be written in terms of the second very straightforwardly. So we could even add that as a convenience method, and we'd be fine. So we choose the second one as the better core functionality for the library. Now, for text formatting, I came up with a lot more alternatives. We've pretty much got everything possible in here. We have some square brackets. We've got some attributes. We've got, I didn't use any, no keyword arguments, but I've got positional arguments. Most of them separate printing from formatting, but the first one combines them together. I have a couple of favorites amidst all this noise. This is the favorite. It's fairly short. It's fairly familiar. It looks a lot like HTML, for example, which a lot of people know. Now, the trouble with this is not all terminals have an escape code to selectively turn off just boldness. Some do, some don't, so we can't depend on it. And so in order to make this work, we'd have to hide state away somewhere, maybe on the string or a parallel data structure. And that makes for both enormous code complexity in the library, as well as mental load and debugging for the user when inevitably something breaks. So what I ended up choosing as the best here was this attribute syntax. And the great thing about this, these attributes simply return the escape codes. The great thing is that it's consistent with, it works with Python's built-in template formatting, this format method. And then to keep the nesting case, that red bold case, short, we introduced this strange little thing, this mashed together method name, red bold. Now, admittedly, this is a bit novel, and I just told you not to be novel, not to come up with clever things. But I kept this example in the consistency section because it illustrates that all these principles are about trade-offs. We can't just turn all the knobs up to 11 all the time, or
No
I
podemos
wouldn't have
irnos
to give
siempre
this
al
talk and all
extremo,
APIs would be
no
wonderful.
necesitaríamos pensar en esto, no estaría dando esta charla.
We'll talk about some of the benefits, the additional benefits
Hablemos
of
de los
this mashed together
beneficios.
syntax in a moment. So if you're going to do something a little weird like this,
Si vamos a hacer
at least
algo
be
medio loco,
self-consistent.
seamos
This joined
autoconsistentes.
mashed syntax is used for everything in
Esta
Blessings.
sintaxis se usa
Formatting,
para todo en
coloring,
Blessings, dar formato,
foreground color,
colores.
background color, everything. It's impossible to get it wrong. You can put the different
Difícil
words
que
in any
salga
order,
mal.
and it just
Los
works.
ponemos en otro
So the user
orden,
doesn't have to
también
keep
funciona.
referring back to the documentation to figure out what's valid. They just internalize one slightly odd idea, and that carries them through all of their use cases.
Una de las ideas y
Another great
lleva todos
example
los
of this,
casos.
also with
Otro
underscores,
ejemplo
oddly enough, is Django's ORM syntax.
Es el
It's got these
ORM
double
de
underscores
Django.
everywhere, and this doesn't
Tenemos
occur
guiones
anywhere in the
bajos.
Python standard library. I mean, maybe before some method names, but not like this. But it's used consistently throughout the ORM. You apply it, you learn it once rather, and then you apply it everywhere.
Lo vemos una vez, lo aprendemos una vez y después.
Now, when you're
se
evaluating
mantiene.
your consistency, there are some warning
Cuando
signs to look out
evaluamos
for.
la consistencia,
Frequently
tenemos que
referring
tener
to your own
cuidado con lo
documentation, for
siguiente.
example, or the source code you've already
Si
written
suelen
as you're
consultar
building
la
your library,
documentación
thinking,
mientras estamos
what did
construyendo
I
la
call
librería,
that? What
¿cómo le
order were the
puse?
document or the arguments
Pensamos,
in?
¿dónde los puse? ¿Dónde
The
puse los
second one,
argumentos?
if you feel like you're inventing novel
La
syntax.
segunda es si
So
estamos
use your judgment here.
pensando que
What I
estamos
usually
creando
think is
sintaxis
make
nueva,
sure your novelty pays off rather than just shows
asegúrense
off.
de que vale la pena y
A
no
third
que
rule of
presume
thumb
nada
is
más.
brevity. This is a
La
favorite of
tercera regla
advanced
es la
programmers
brevedad.
everywhere. Sometimes
Este
we
es mi
overdo it.
favorito.
I like to make common things
Me
short
gusta hacer
in
cosas
tokens,
comunes cortas.
sometimes even in terms of characters if it doesn't hurt
También
readability.
en cuanto a caracteres, si no
Here's our
afecta la
excerpt from
legibilidad.
earlier, and
Hay un
now you'll
extracto
see
de lo
why this
anterior
mashed together
y
naming
veamos
makes
por
such a good
qué
shortcut.
esta sintaxis compactada
So here's a
es
very,
tan
very
buena.
common use case. Setting some formatting, printing a string, and then
Para dar
returning to plain
formato,
text. Since it's the
y
most common,
pasarlo a
we
texto
make it the
plain.
shortest.
Es bastante
So
común,
this
entonces
new
la
line
hagámosla corta.
is equivalent to the line just above it.
Entonces acá tenemos un
But
equivalente,
not everything has to be brief, of course.
pero
If
no
we're doing
todo
something
tiene
a
que
little
ser
more
breve. Si
interesting or
queremos hacer algo un
unusual,
poco más interesante o inusual,
it can be a little bit longer. This is what
puede
you
ser un
might do
poquito
if
más
you were
largo.
trying to optimize the
Esto es
number
lo
of
que puedes
bytes
hacer si quieres
going through the
optimizar
terminal.
el
You had a
número
very
de
slow
bytes que van a la
modem or
terminal.
something. You set bold, you set red on top of it, and then you
Podemos
return to
decir
normal.
bold, red arriba.
Another way to think of this is when designing your
Otra manera de
API,
pensarlo,
your users
cuando
should only have to
diseñes
pay for what they eat. Think of it like a restaurant.
una API, los usuarios deben
Ask
nada
yourself
más
these
que pagar
questions
por lo
about
que
brevity.
comen.
Do you find yourself copying
Pregúntense
chunks of code
lo
from your
siguiente sobre
examples? That's no good.
brevedad.
They're too long. Make it
Se
shorter.
encuentran copiando código de los
Do
ejemplos
you
porque
find yourself
quizás es
typing
demasiado
something
largo.
irrelevant, saying, "Oh
Estamos
boy,
tipeando
I
algo
wish
relevante.
I didn't have to say yes, one or
Ojalá no
true.
tenga
It should
que
always be true. You should be
pasar
able to assume
siempre
it's true." Well, that's
probar
what a
algo
default
si
smells
siempre va
like.
a
That should
ser
be a default.
verdad.
A more
Ahí
subtle
tenemos
way
un
that
default.
something that should be
Otra
defaults
manera
can
de hacer
manifest is
listas
through
largas.
long argument lists. When you're passing 7 arguments into each method,
Cuando pasamos
maybe those should
a
be
argumentos entre
methods on
todos
a
los
class, and you
métodos,
instantiate the class once and then call a
los
bunch of
datos son
methods on it.
complicados, mejor ponerlos en una clase.
Making your abstractions composable. It means being able to
Hagamos
reuse them in
nuestras
many different
abstracciones
ways and
posibles de
plug them
componer.
together in ways you haven't anticipated.
Lo podemos
Your users
compactar y
will show you
usar de manera
things that
que
you
las
never
podamos
intended.
reusar.
They're very creative. And there are a million ways to say this.
De maneras
Flexibility, loose
imprevistas. Hay
coupling,
muchas maneras de
small pieces
llamarlo,
loosely joined.
flexibilidad,
But no matter what you call it,
piezas unidas,
it all comes down to the minimization of
pero
assumptions.
siempre se reduce a
And there
la
are 2 ways you can
minimización
go
de
about this,
suposiciones.
one of them wrong.
Podemos hacerlo de dos formas. Una está mal.
Let's go back and see another way we could have done blessings. We could have chosen
Vamos a ver cómo
to
podríamos haber
hook
hecho
printing and
blessings.
formatting together.
Podríamos haber
Now, my friend Jeff Quast put
usarlo
together
de
a really
sola
neat
vez.
BBS system
Mi
called
amigo
X84.
Jeff Quast
And it works over Telnet
creó un
and uses
sistema que se
blessings
llama
for its formatting functionality.
X84, trabaja
It's got a
en
multi-process
usa
design like
blessings
Apache.
para
There's a
un
server
diseño
process
diseño
where all the formatting
multiproceso.
takes place. And then each connection to a client is handled in its own client process that hook back to the server using a socket. Now, with this, there is no way to pass that output to the children because it's going off the terminal all the time. It's going off the terminal. You can't help it. Now, the wrong way to solve that would have been to add an option. This is the tempting thing to do. Oh, I already coupled these together. Let me just add a flag, right? No. What's wrong with this? Well, it makes everything more complicated. We need to add a branch in our code to handle the option. We need to document the option. We need to write a test to exercise that branch in our code. So whenever I think about adding an option, first I look around for any other escape route. A better way, of course, is to break that coupling at the assumption point so that printing and formatting are separate. Now, because we followed the composability rule of thumb with blessings, Jeff was able to go ahead and stick formatted strings in memory and pass them between processes, even though he started x84 10 years before blessings existed. He's an old school BBS hacker. It was an easy retrofit because it didn't make many assumptions. So look out for these red flags about composability. Classes with a lot of state, a lot of instance variables, make me think that there are multiple little classes in there just struggling to get out. For example, I wrote a library called PyElasticSearch that talks to Elasticsearch from Python. And Elasticsearch is it's a document store. Clustered document store. It likes to have lots of different machines hooked together, and it figures out the clustering on its own. It's quite nice. That's the elastic part. Now, because of the clustering, one feature we needed was a penalty box. We needed to notice that this node I'm trying to talk to is not responding. And think to ourselves, well, I'm not talking to that node for another 5 minutes. I'll go over here and talk to this node. Now, at first, I was tempted to add that, in fact, I did add that, directly to this Elasticsearch connection object, along with all the other things that it was responsible for. And then I started to smell a lot of instance variables in there. And so I thought, well, let's break this off as a separate class. And here's our decoupled composable penalty box. Now, here are some cool ways this can be reused. The penalty box makes very few assumptions. It doesn't know about networks. It doesn't know about URLs. It doesn't know anything about Elasticsearch. All it has is arbitrary things you can fill it with. You can ask for a random thing, and you can tell it, hey, this thing isn't responding. Punish it. Put it in a penalty. And as a result, we can reuse this any place. We need a penalty box. We can use it in games. A second warning sign is deep inheritance hierarchies. Now, people say composition is better than inheritance, and here's why. If you inherit, that's the easiest thing to do, right? You get ready access to all the methods and data of your superclasses. But the trouble is, you get a lot of responsibility with that capability. You inherit all of the invariant baggage of your superclasses, all that responsibility to tiptoe around its instance variables and not make them invalid in combination. You have to not make them invalid, but the language doesn't help. The language says, sure, you can write to those private variables, you can do whatever you like. It's Python, we're all friends here. So subclassing just increases the amount of code that has to tiptoe around that state. Instead, it's often better to instantiate that would-be superclass and put it inside your object as a variable. Now, subclassing ran amok in Zope 2. I used to do a lot of Zope 2 work. And we had inheritance hierarchies 20 or 30 classes deep and multiple inheritance. We had to build this tooling called the DocFinder tab just so that we could guess where a method might be defined, maybe. In that case, that wasn't enough fun. We invented a whole sideways kind of inheritance that was dynamic and could only be figured out at runtime. So, yeah, don't make the Zope 2 mistake. There's a reason everyone runs out of the room whenever someone says Zope, and I thank you for staying. Then we have the law of Demeter. Now, this is cool. This works in every language. And basically it says, if you do compose, no cheating. Now, if the Elasticsearch object contains a penalty box object, then the outer object can feel free, of course, to call methods on that inner object. You can call methods on the penalty box. Here's a node give me a node, punish this node. But you're not allowed to drill farther in. We're not allowed to say, oh, let me see what's in that penalty box. Let me grab one of those URLs from there and let me uppercase it and stick it in a data. No, don't do that. We have to maintain abstraction. If we don't maintain abstraction, then there was no point in separating those objects to begin with. Mocking. Who uses mocking in tests? I have to do that sometimes too. But every time I feel really bad about it. You should feel bad too. I find that if I'm mocking out too many dependencies in my code usually has too many dependencies, makes too many assumptions. For example, how would you test this? Well, since it's all coupled and assumes it's going out standard out, you'd have to go into the sys module and mock out standard out, and then maybe put a string IO object in there. There's another library you need string IO. And then you have to pull the value off of string IO, and then you need to remember to put sys back how you found it, because otherwise, who knows what's going to happen. So you probably need a mocking library to help you remember to put things back how you found them, even if the test crashes. It just makes for a lot of code. This, on the other hand, doesn't need any mocking. It's straightforward. You just call format and say, yeah, assert this equals that, and you walk away, and you're done. Testable code is decoupled code. And then, of course, look out for profusions of options. Another rule of thumb that helps with reusability is plain data types. Whenever possible, express your API, its inputs, its outputs, as native to the language data types. In Python, strings, integers, dictionaries, all good. Not big custom classes that you have to construct and pass into your methods, and then you get them back, and you have to look up documentation to see how to get stuff back out of them. Because it's likely that the rest of your program is not written in terms of those custom objects, right? You're going to have to convert back to native data types anyway. So you might as well save the step. The aim should be to reduce barriers to reuse. And here's an example of a barrier. This is the config parser class out of the standard library. And its purpose is to read INI files. Who's used config parser? So I've used it as well. And unfortunately, it is not just a parser. It doesn't just read the file and give you back something simple like maybe a nested dictionary, for example. Instead, it sticks around forever and returns this big config parser object, which you then have to express the entire rest of your program in terms of. Now, the trouble with this is the config parser object does not conform to any Python language idiom. This means that any code that calls config parser has to be written in terms of its weird method calls. So you're stuck with config parser forever unless you want to rewrite your program. If you wanted later, for example, to have the flexibility to read maybe YAML files or some other kind of configuration, maybe pull configuration out of a database, you'd have to put a facade around this, or replace it and rewrite, or wrap it with something. Extra code, extra trouble. Now, I'm going to continue picking on config parser, and I'll pretend that it has a slightly worse API than it does, just for the sake of argument. Let's pretend that there's a read method, which there is, and let's pretend it takes a single file name, which it does not. Now, this might feel like a convenience, because, of course, it's very common to read configuration out of a file. But if that's the only way of getting configuration in, then that is a barrier to reuse. A method should take what it needs, the minimum thing it needs, and nothing more. We need, in this case, a string. The configuration is always a string. We don't need a file. It's not 500 megabytes of configuration that we need to seek around in or load incrementally. It's probably a 10 to 20K config file, and memory is big. So I would introduce a parse method that takes a string, and that would be the core method. And then if we want, we can also add a convenience method that wraps it. Something like, well, we can give a file contents function, a utility function that turns a file name into a string, or we could also have this read method that it comes with. But we also need parse. Imagine trying to write a test that has to set up some configuration first. We don't want to be writing out temp files in our test and then reading them in and remembering to delete them. That's a lot of extra code. Fewer assumptions makes everybody happy. Now, even when you have a more inherently complicated data structure, expose as much as possible using built-in or native data types. One of my terrible libraries is called SpiderFlunky. And it is, I suppose, a client of SpiderMonkey, which is Mozilla's JavaScript engine. It uses SpiderMonkey to parse some JavaScript. And then SpiderFlunky knows how to walk around the abstract syntax tree and return interesting information by function calls and variables and such. Now, to walk this abstract syntax tree, I needed a doubly linked list, a doubly linked tree, excuse me. Now, there aren't any of those in Python. We could have nested lists, but that only links in the one direction. I needed to be able to climb back up the tree. So I had to make a class, and I felt bad about it. But there you go. However, I got back to native data types as soon as possible by, well, in this case, adding a walk-up method. We are transforming here the doubly linked tree back into a native Python thing, the iterator. So I can say something like, for example, well, let's take a look here. I can find the nearest scope in JavaScript by walking up from any line, or any node, just with a nice little generator expression. I can say, hey, for n in walk up the tree, take the first one that looks like a function declaration or is just the global scope of the program. So if you can't have plain data everywhere, at least return to it as soon as possible. Plain data warning signs. If your users are immediately transforming your routine's output into something else, just return the something else. If you are doing the reverse, if you are requiring them to make some big object and then pass it to your routine, why not just take the components if you don't expect that they'll be reusing that bundle of attributes? And then, of course, if you find yourself re-expressing, respelling things that the language already provides in different terms, like config parser, with its get section option, I mean, that would just be dictionary, square brackets, one key, square brackets, another key, right? That's already built in. Why change it? Now, grooviness. Let's see how this translates. In English, there is this idiom of being in the groove. Like if I were running a marathon, and the first mile it hurts, you're not really warmed up, it's uncomfortable. But then miles 2, 3, 4, you start to settle into the groove. You're feeling okay, things are heating up and you're loosening up before you get tired at the very end. And I have this same idea in my APIs, that users should spend most of their time in the groove, in this period of ease. And you can even bring more physical metaphor into it. Think of programming as walking across a plane. And I'm kind of walking in this worn path, this groove here. I could close my eyes, and if I walked over to the right, I could feel that the groove was sloping up, and it would tend to push me back down into the groove, where I'm more comfortable. Now, of course, there's nothing keeping me from stepping out of the groove if I needed to. And then I could step back in when I was finished. But the groove is attractive, and new users are drawn there without really needing to be dragged. Let me give you a few ideas on how to cut grooves in your APIs. First, avoid nonsense. Let's talk about PyElasticSearch again. Now, there are two different ways to query Elasticsearch. You can use this big, powerful JSON that's long, or this little simple string that's short but not as powerful. There's no such thing as a query that uses both. You have to choose exactly one. But this is what the old PyElastic search routine used to look like. Notice that all of the args are optional. So you'd pass in string-style queries using the QArg, and JSON-style queries using the body arg. I don't know why. Of course, that meant nothing stopped you from doing this or even this, both of which are complete nonsense. Certainly, you shouldn't need code in your library to check for this sort of silliness. We should be able to make the language fail. Now, the new PyElastic search replaces that mess with a single routine that takes a single argument. Query. If you pass a dictionary in, you say, oh, that's JSON. If you pass a string in, well, it's obviously a string. You can't mess it up, and it's much groupier. Now, incidentally, this turns up another principle, which is to fail shallowly. In our case, the interpreter would give us a type error, like a type error, if you have the wrong number of arguments. Failing shallowly is something that's nice in a language that gives you tracebacks. But if you're using a language like JavaScript that might not give you very informative tracebacks, it's vital. So in JavaScript, I can't tell you how many times I've spent a weekend just crawling through the debugger trying to figure out how an undefined or a nan got into some object attribute. Where did this thing come from? I wish it had just crashed with a key error when I, accessed this non-existent key or did this weird math thing. I actually got to talk to Brendan Eich, the inventor of JavaScript, and he told me why it was like that. I mean, JavaScript was never really intended to be used for large projects. They figured, oh, we use it for a little animation or something, or to scroll a marquee in the toolbar. And it was just designed to keep on going no matter what went wrong, right? Because whoever's looking at the web page is probably not a developer. There was no such thing as JavaScript development tools then. There was just alert. And so JavaScript was just designed to keep on going no matter what went wrong. That's why that decision was made. And now, of course, we're stuck with it. That's legacy for you. So don't make that mistake in your APIs. Another way to provide grooves is RAII. Here is a poppable balloon class. But as you can see, when you first make one in init there, it has no air in it. So if you tried to pop it, it would just go squish, maybe. Now, you could imagine writing some documentation that says, hey, before you pop the balloon, make sure you fill it with air. But that's kind of a design smell. When you start writing documentation, especially along the lines of make sure you do this, makes me think maybe I need to go back and improve my design so that you can't screw it up. A better way would be to take the initial fill amount on construction. Take, 10 cubic centimeters of air at STP, for example. The user is required to provide it. They get a prompt error message, a type error, if they don't. And, if they want a balloon with no error, they have to pass 0 explicitly. So there's no wondering why I pricked the balloon and nothing happened. So RAII is just a case of don't have invariants defined. Now, a final way of providing grooves is through compelling examples. And these are the most overt sorts of grooves, but I think also the most enjoyable. Now, this screenshot is from MacPaint 1.0. Who's used MacPaint 1.0? I'm the oldest person in the room. It's official. But I bet you recognize this layout. The palette on the left, tools, and menus on the top. Menu items in the title bar. There's a title bar there. I mean, this looks familiar to everyone in the room because Illustrator and Photoshop and PaintShop Pro and the GIMP and Pixelmator have all been copying slavishly for the last 30 years. Another example, Nintendo side-scrollers, right? This is 30 years ago now, 40 years ago, a long time ago. But even today we are still jumping and running to the right and defeating enemies and collecting goodies. If you set a good example, people will follow it happily forever. Now, I used to write example code for my libraries in a very pedagogical fashion. Long names, big comments everywhere explaining everything, inefficiencies for the sake of clarity. And I ended up being forced to stop doing that because people were actually copying and pasting the code right out of my examples, sticking it in their production systems and wondering why is this performing so slowly. They would even copy my comments and stick them in there, even if the comments were completely out of context. So don't underestimate the docility of your users. They will happily do whatever you recommend. So recommend suitable things. Maybe take those comments and pull them out of the code into prose around your code excerpt. So with grooviness, look out for nonsense states. Look out for invariants that aren't really invariant. And then watch users if you can. Watch someone at a sprint get started with your library. And don't prompt them too much. See if they know where to start without referring too much to documentation. The tech writers in the early Macintosh project played a large role in making sure users could discover organically how to use software. They would come back to the programmers and they would say, so I'm like 5 pages into describing this feature now, and that's a lot of paper. Maybe we should make this feature easier to use. And they would tear it all down and they would start again. So if your API is hard to explain, maybe it's too complicated. Go back, see if you can simplify the design. Incidentally, this is why I like README-driven development. I tend to write the README first, full of examples of call sites, and then all I have to do is make that work. Now we get to the walls. So walls are to keep you from hurting yourself or others. Just as in the physical world, there's a continuum between grooves and walls, a bit of a slope. The more damage you can do with a feature, the higher the wall should be in front of it, the meaner the barking dogs, the more razor wire. Here is a horrible API with not enough walls. And who sees what's wrong with this? Yeah, maybe it's bitten you in the past like it has me. Who here has wiped out a whole database column because they forgot the where clause? I've done it. Yeah. One way to fix this in the design might be to require you to say all if you mean all. Maybe it's less mathematically beautiful, but most of us aren't mathematicians, and beauty aside, imagine all the hours and pulled hair it would have saved since the beginning of SQL. I mean, that one little word, right? Save a whole industry. Here's another old chestnut. This is good. This is a pretty common thing to do in Python 2, anyway, Python 2. But the trouble is, to do this, first you have to type this. Yeah, it's seriously bad news. Now, don't hit return too early. Now, fortunately, a lot of shells, my shell included, I just tested this the other day, have put up a wall in front of this. If I enter this, it'll say, hey, no, you need to say -F if you want that to work. Very nice wall. I'm sure it saved a lot of trip stack backups. A similar sort of thing, actually the exact same thing, we never learned, happened in Elasticsearch. This is what the delete method used to look like. It deletes a document based on its ID. Document is like a database row. Now the thing is, the Elasticsearch delete method, the REST API, if you don't pass it an ID, it'll happily delete all your documents. Isn't that great? It's very convenient. And here, ID is optional. So how can we fix that? I mean, I can certainly imagine leaving it out by accident, or I think I've typed the ID, but I've omitted the doc type. Oh, it's just terrible. So here's how we fixed it. Now ID is, pardon me, mandatory. And then we added a second method called delete all for those weird cases where you actually want to delete all the documents. You can't possibly screw this up by accident. You can only now screw it up on purpose. And then the other thing to consider about walls is how to report errors. In Python, like in so many languages, you have 2 main choices. You can return something, or you can throw an exception. And raising an exception is almost always the better choice here, since it reduces the possibility of accidentally ignoring an error. So watch out for documents that say remember to, or make sure you, or especially like make sure you do this first, or make sure you do this afterwards. That smell is that's the smell of a context manager you detect. That's the wonderful thing about Python. You say, hey, with opening the file, and then it'll close the file afterwards. Second, ask yourself what the most damage you can do with your library is, and then make sure there are nice walls. You can't do those by accident. Now, there's a cultural thing here. You need to make sure that, well, be aware that your users are not going to report things that they perceive to be their fault. I made a mistake, and I deleted my entire database. You know, it's the sort of thing that manifests in documentation as, oh, you know, make sure you put on that asbestos mitt before you grab the red-hot doorknob, you know? No, that's a design mistake. That's not user error. Why do you have a red-hot doorknob in your design? That's, no. Take that away and actively watch out for your users' well-being. So here are the 7 principles, all summarized, and I like to keep this checklist out on the desk when I'm designing an API. You know, when I think it's pretty good, I look through here and see if I'm making any obvious mistakes. But let me get meta for a second. You may have noticed that there were no big black lines between these principles. Some of them just kind of flow into others. Using plain data helps with composability. Brevity is an aid to grooviness because it makes it easier to remember things. So I started to wonder, does any order arise out of the relationship between these principles? And it turns out that it does. If you lay all these out, and then you connect them with arrows that mean this contributes to that, they divide almost perfectly into these 2 clusters. Now, the left cluster seems to be human things that are qualitative, compactness and grooviness, things that are for human comprehension. And the things on the right maybe are more calculable, things that might have an absolute impact on the number of lines of code in the system, not taking human comprehension into account. So if you like, the left is lingual, to put a nice symbol on it, and the right is mathematical. Now this was a pleasant surprise to me because when I was a senior in high school, I was told that programming is, basically math. And that made me sad because I had already done some programming and I had never done anything more complicated than multiplication in it. Didn't seem to need any particularly difficult math to get things done. And so I really didn't believe it. And even today, I'm more of a lingual thinker than a mathematical thinker. But we can see how the 2 meet in the middle and that both are necessary to make a program that actually is functional and comprehensible. The math-language duality also highlights the thing that programming languages have over and above ordinary languages. Programs are alive. They not only mean things to people when they're read, but they actually do things when they're run. So, in a very literal sense, a program with carefully chosen symbols is poetry in motion. Muchas gracias. I want to thank my good friend Ricky Rosario for translating my little quotes. I hope you're watching, Ricky. Thank you, Melina. Thank you for translating for everyone so that I could not have to learn Spanish in a month. That was wonderful. Yes. And thank you all for coming. ¿Preguntas?
¿Alguna pregunta?
Very good. I can hear hear you. Talk loud. Sí.
El machete, el que está al final,
I will
está
make it a PDF
disponible
or better.
online.
I will make it
Lo haré.
text so that you can mix it. I'm sorry, I will repeat the question. The checklist, will it be available online? Yes.
Si la checklist va a estar disponible online, sí.
I will tweet it out. I'm
Lo voy a
Erik
mandar por
Rose on Twitter.
Estoy en Twitter. El problema es librerías. Es muy complicado para entender. ¿Cómo le puedo atacar al problema?
So let me ask you a question about your library, and the question I should repeat was, and let me know if I got this wrong. You have a library to extract from your program, but it still seems too complicated to use without a lot of documentation. Is your problem inherently complex? Is it your static analysis thing, for example, we were talking about last night? Cache.
Es sobre efectivo.
Well, maybe we can sit down and take a look at it.
Quizás podamos sentarnos y mirar.
What I try to do with documentation, and I always do end up writing documentation, I'm not saying you should never have documentation, is give an overview of the concepts that you will need to understand this library. For example, with blessings, I'll say things like, there are these terminal escape codes, in case you weren't familiar with them. Now here's how you get them out of blessings. Oh, boy.
¿Cuál es tu API favorita?
There are a lot of good APIs out there.
Hay muchas buenas APIs.
I think probably my favorite API would be
Creo
the Python iterator API. It is so pervasive, and because of its pervasiveness, so useful. You could iterate over lists, over dictionaries, over dictionary keys or values. You can iterate over, oh boy, sets. Everything is iterable in Python, just like everything is a hash table in Python. And because of that common interface, you can mix any two things together in Python. You can for loop around anything. You can while loop around anything. You can even go into the func tools library and pull out, the context manager decorator and context manage around an iterator. And we can see what a good idea it is because JavaScript is stealing that. Yes.
¿Qué crees sobre static typing?
What do I think about static typing and the information it provides at the level of API design? It's interesting that you asked that now because I have had my thinking evolve on that point over the last few months. I dislike typing. I dislike typing, not typing. And so I've always I've always liked my languages to either be dynamic or to infer types. I still like type inference. I think Swift, have you seen the Swift language? I think it makes a good trade-off. It does type inference, but it either forces or encourages you to specify types at the method signature level. I've noticed that in Python, which has no annotated types, I end up writing the type information into the doc string anyway, and then it's not in a standard way, right? And maybe you document your program in Espanol, and it's harder for me to read. Yeah, so I actually think that the types are useful at the level of function declarations. They give you something to go on. Now, of course, you'd want as rich a type as possible. String is not the best type for a URL. It would be nice to have a type URL. That's what I think about static types. Audrey.
Audrey. Me pregunto si tienes algún consejo para los mejores paquetes para.
A very good question. What do I do with my great ideas on how to fix my old APIs to be better with they're already in use? So you have two big choices here. One is we never run out of integers. You can always release a 2.0 and say, all right, everybody, change your stuff. Here's 2.0. Everything is different now. I tend to use semantic versioning. Even in more iter tools, which is an iterator library of mine, I changed one routine signature from a tuple to a list, and I bumped the whole major version for that. Better to be safe than sorry. The other way is, this is where I can be prevailed upon to introduce options to things. I think this is a good use for options. As if it's just a simple behavior switch, for example. And of course, you'll have to write a test for that and documentation and everything. But if it improves life for your users, great. The other thing you can do is break things into smaller composable units. So I can go back to Elasticsearch. We had there's this bulk loading API in Elasticsearch for grouping lots of inserts or other operations together in one HTTP request and sending them all at once. I had this huge routine for being able to specify, here's a get, here's a put, here's a get, here's a put, here's another get, and another get, and it became a very complicated routine. Maybe that, with so much complexity, would be a good place to actually go ahead and create smaller intermediate things which you pass in. And then you have other external routines that create those smaller intermediate things. And then you can replace those little intermediate routines and deprecate old ones. You may not have that pattern, but it's an idea. Four-dimensionality is not a solved problem in software. The future is hard to predict. There was one over here. Yes? Oh boy. A fun question. What do I do at Mozilla? How do I get to apply all this stuff? I work on a static analysis and search package. I guess it's going to be a Python package soon, called DXR. I'm going to try to work the conference internet. It's never a good idea. But DXR is a tool for making sense out of large code bases like Firefox. 16 million lines of code, and because of DXR, we can do a regular expression search on all that code in 80 milliseconds. It also does a little bit of static analysis, like where is the function defined, who calls this function, who uses this type, if I change this function, who will become angry at me, that sort of thing. And the API design, well, it's not just for libraries. In fact, it's even more fun if you're not writing libraries, because then you won't disappoint people who are calling in from the outside. Every time I make a function, I'm defining an API. And every time I name a variable, I'm defining a memorable word that hopefully describes what's in the variable. So you never stop designing APIs. You can't escape it.
Nunca paras de diseñar APIs.
Sure, yes. We do a lot of code review at Mozilla. Most of our projects work on what I call the buddy system. We have a team of 5 people. If I want to put some code in, I open a pull request, and then anybody else can sign off on it, and then it goes in. And very rarely do they not find some mistake in my code. It's very rare.
Es bastante raro encontrar errores en mi code.
Más preguntas? All right. Thank you very much.